Hello everyone. Thanks for joining us as we bring you the latest on a developing weather story that's capturing the attention of millions across Europe. Today is the 28th of October, 2025, and Europe is facing an extraordinary weather situation that could have far-reaching impacts on daily life, infrastructure, and even the economy. Forecasters are warning of an unusually wet and stormy period stretching from late October through at least the middle of November, with some experts suggesting the unsettled weather could last even longer. A vast atmospheric setup over the North Atlantic is pulling moisture-laden air towards Europe, setting the stage for serious rainfall. This conveyor belt of moisture is sometimes called an atmospheric river, and it can deliver relentless rain for days on end. Weather models from multiple agencies show a strong consensus on this extended period of unsettled weather, with repeated waves of storms expected to sweep across the continent. Many regions will experience persistent rain, with some areas bracing for exceptionally heavy downpours that could last for hours or even days at a time. The ground is already saturated from previous rainfall, raising the risk of flooding for millions. Rivers and streams are running high, and low-lying areas are especially vulnerable. Unseasonably mild conditions are also part of this story, with temperatures well above average for this time of year. This warmth is unusual and is helping to fuel the storms. Warm air holds more moisture, leading to torrential downpours when that air finally cools and condenses. This means rainfall totals could be much higher than normal. The primary hazard is widespread flooding, both slow-rising and sudden flash floods. Urban areas with poor drainage and rural regions near rivers are both at risk. This isn't just an inconvenience, it's a serious threat to safety, property, and essential services. Emergency responders are already preparing for possible evacuations and road closures. Let's dive into the science behind this pattern to understand what's happening and why this year is different from previous autumns. Stay vigilant over the coming weeks, keep an eye on local forecasts, and make sure you're prepared for rapidly changing conditions. What's behind this relentless stretch of wet weather? Why does it seem like the rain just won't let up, day after day? The answer lies in a powerful, large-scale atmospheric phenomenon known as a dipole, a kind of tug-of-war in the sky that shapes our weather for weeks at a time. Picture two enormous weather systems, a stubborn high-pressure zone sitting over the Atlantic and a persistent low-pressure system parked over Europe. These two giants act like bookends, holding a corridor of turbulent air in place. This setup forms a stable, fast-moving channel in the atmosphere, almost like a river in the sky, carrying warm, moisture-laden air from the Atlantic straight into the heart of Europe. This atmospheric river acts as a conveyor belt, funneling vast amounts of water vapor across thousands of kilometers. The ocean's warmth supercharges this flow, loading the air with even more moisture. The high and low pressure systems act like walls, locking this moisture channel in place and preventing the usual shifting of weather patterns. The result? A relentless, unbroken stream of rain. Instead of the rain coming and going, it lingers, sometimes for weeks. Streets, fields, and forests are soaked day after day, with barely a break in the clouds. The air, heavy with water vapor from the warm Atlantic, releases its load as steady, soaking rain. Hills turn misty, farmland becomes waterlogged, and rivers begin to swell. The dipole even bends the jet stream, a powerful wind high in the atmosphere, aiming it directly at Western Europe like a fire hose. This keeps the wet weather locked in place, amplifying the effect. Normally, weather systems ebb and flow, bringing variety, but under this pattern, the usual rhythm is lost, replaced by a stubborn, unyielding wet spell. The ground can't keep up, soil becomes saturated, puddles linger, and the risk of landslides and erosion increases. Water has nowhere to go. As the rain continues, rivers rise and overflow their banks, streets and towns face widespread flooding, disrupting daily life and threatening homes and infrastructure. This isn't just a forecast for more rain. It's a warning of significant flood risk. Communities must prepare for the challenges ahead, as this persistent pattern shows no sign of letting up. Every big weather story has a beginning, and for this wet spell, it started with Storm Benjamin. On October 23rd, Storm Benjamin swept across Western Europe, intensifying rapidly. It unleashed powerful winds and heavy rain, causing significant disruption. The storm's heavy rainfall began saturating the ground in the UK, Ireland, and France. Benjamin's most significant impact was altering the weather pattern across the North Atlantic. it destabilized the jet stream, locking the atmospheric dipole pattern in place. While Benjamin has passed, its legacy is the persistent, rainy weather pattern. It set the stage for the continuous flow of moisture from the Atlantic. The ground, already sodden, has little capacity to absorb more rain. This makes the risk of flooding much higher. Remember, it all started with one powerful storm. Why is this air so wet? It's a question that's becoming more urgent as we witness record-breaking downpours and flooding in cities around the world. The answer isn't just about local weather, it's rooted in the fundamental physics of our atmosphere, and how it's changing as the planet warms. At the heart of this mystery is a scientific law known as the Clausius-Clapeyron relation, a principle that helps us understand how temperature and moisture interact in the air. This principle states that for every degree Celsius of warming, the atmosphere can hold about 7% more water vapor. That means even a small rise in temperature can dramatically increase the amount of moisture in the air. Think of the air as a giant sponge. When it's warmer, it can soak up and retain much more water, making the atmosphere primed for heavy rainfall. The air currently being funneled toward Europe is coming from the warm subtropical Atlantic, where ocean temperatures are unusually high. These elevated sea surface temperatures act like a supercharger, loading the air with even more water vapor than usual. The warmer the ocean, the more moisture evaporates into the air above it. By the time this air mass arrives over Europe, it's super saturated, carrying an exceptional amount of water vapor, ready to be unleashed as rain. As this moisture-laden air moves over cooler land or is forced to rise over mountains, it cools down. Cooler air can't hold as much water, so the excess moisture condenses and falls as rain, sometimes in torrents. This is a direct consequence of a warming world. As global temperatures rise, these natural processes are amplified, making extreme weather events more frequent and severe. The Clausius-Clapeyron relation means that with every degree of warming, the potential for extreme rainfall and flooding increases, putting more communities at risk. Warmer air simply holds more water, and when that water is released, it can lead to intense, sometimes catastrophic, rainfall. The science is clear. More water in the air means more rain can fall, and the risks of flooding and damage are rising. That's why understanding the science behind a super-soaked atmosphere is so important, because it helps us prepare for the dangers ahead. Let's examine those warm seas. The oceans are a massive reservoir of heat energy, influencing our weather. This year, the North Atlantic and Mediterranean Sea are exceptionally warm. Sea surface temperatures up to 3 degrees Celsius warmer provide moisture and energy. Warm water evaporates more readily, saturating the air with moisture. The atmospheric river is carrying an amplified amount of water. Warm water also provides heat energy, making storms more powerful. The Mediterranean Sea creates an unstable environment for thunderstorms. This combination of moisture and energy makes the situation volatile. The sea acts like a battery, energizing weather disturbances. Warm seas mean heavier skies and dangerous weather for Europe. Let's talk about mountains. Mountains shape our weather, determining where and how much rain falls. The process is called orographic lift, a major factor in the coming weeks. Moist air from the Atlantic is forced up and over mountains, cooling and releasing rain. Windward slopes of mountains will be much wetter than leeward sides. The Alps, Pyrenees, Apennines, and Dinaric Alps will experience this effect. Mountains focus rainfall, leading to high totals and flood risk. This orographic rainfall will be sustained, dumping water into river basins. Mountains squeeze rain through orographic lift, but convection is another threat. Convective rainfall is linked to thunderstorms, a major threat near the warm Mediterranean. Convection happens when warm, moist air rises rapidly, forming towering clouds. This process releases energy, fueling powerful thunderstorms. Quasi-stationary storms dump torrential rain over small areas, causing flash floods. The Mediterranean region is primed for this activity. The sea acts like a hot plate, providing heat and moisture. Intense thunderstorms will hit coasts of Spain, France, Italy, and the Balkans. The main danger is flash flooding, overwhelming drainage systems. Be prepared for rapid changes in conditions. We can pinpoint high-risk areas across Europe for the next few weeks. Awareness of these zones is crucial for safety. The risk is concentrated where geography interacts with the weather pattern. Western and southern slopes of the Alps, Pyrenees, Apennines, and Dinaric Alps are at risk. These areas face large-scale river flooding and landslides. The Mediterranean basin is at high risk for intense convective rainfall. Coastal areas of Spain, France, Italy, and the Balkans are vulnerable to flash floods. Some areas may experience both orographic and convective threats. Western Europe, with saturated soils, faces river and surface water flooding. Understanding these risks helps communities prepare. Understanding the science is fascinating, but staying safe is crucial. With hazardous weather ahead, being informed and prepared is your best defense. Use resources to track the situation and receive timely warnings. National weather services provide detailed forecasts and warnings. Meteo alarm aggregates warnings across Europe on a color-coded map. A red or orange warning indicates high potential for dangerous weather. Check these resources daily. The European Flood Awareness System offers a continent-wide flood risk overview. If you live in a flood risk area, have a plan and an emergency kit ready. Europe faces a significant period of wet weather, driven by stable patterns and warm seas. The primary dangers are river flooding, flash floods, and landslides. Stay informed, understand local risks, and take precautions to navigate safely.